Hello, hi everyone. For today's video, we're going to configure our LTM um, from scratch. Okay, so basically, we're going to configure. Um, Let me tell you first the topology. We have a topology. In our topology, we have a Windows 10 that has a 10.10.1.4 IP address, and connected to our F5 LTM. It will connect to our front end connection. Then it will go to our backend connection. Backend pool members are these are the servers 172.16.20.1.2 and .3. First, we're going to configure VLAN external and internal interface from our LTM. Then we're going to create an interface self IP for external and internal. And then we're going to configure virtual server for our HTTP and HTTPS. Then we're going to configure also the full members of this VIF. Then we're going to use round robin for our. Then we're going to verify it. Then we're going to configure also health monitor and use other health monitor like ICMP or HTTP, HTTPS. Then we're going to configure the priority group and verify if it's working. Then we're going to test to try to force offline other full member if they are really not getting the traffic if we force offline. Then we'll also try to enable packet capture in the LTM, and I will also try to show you and how to download those packet capture from LTM to your laptop. Then we're going to read and analyze packet capture. Okay. Okay, let's try to access now our LTM. This is our management IP in our LTM. So I'll put it here. 192.168.2.3.4 admin and put your password. Okay. Default is default password admin. So we have now only 3 days license because I have 30 days license, but 30 days license is left, so it's good to create a video for this one. So in our interface, we have 3 LAN interface. We're going to use this one 1.1 for our external. Okay, then we're going to use this one for our internal, and this 1.3 we're not going to use it. Okay, so in our list, we need to first to configure the VLAN external internal interface. So all you have to do is go to the VLAN, okay, VLAN list, then create and type the name of your VLAN. So I will use external. So maybe I will use the same name, or I'll make it external like this for a proper name. Okay, then we're going to use the interface 1.1. Then we are going to use and tag. Okay, then add. So now we have the external. We can click finish, but since we're doing it again for the internal, I will create repeat. It will save this configuration and we'll create a new one. Okay, repeat. Okay, now we're going to put internal. Okay, then we're going to put internal like this. Internal for the description. We're going to use 1.2 for our interface, and tag also, then finish. So now we have external and internal for our interface. External, we're using our interface 1.1, and internal, we're going to use our interface 1.2. So we completed our number 1. So we'll go to our number 2, create interface self IP for for external and internal. So we're going to click interface, then we're going to click self IP. We're going to create self IP for our external and internal. So create, let's put name, external self IP. Okay, so we'll copy our self IP. This is our self IP. Okay, so we're going to use /26, /16. Okay, then we're going to use external, since this is external IP. Then we're going to we'll use non-floating because this is not the floating IP. This is not the floating IP. We can create floating IP if we're going to use another box. That floating IP will float from other device. Let's say you have active and standby setup, right? You can do that one. So I will click repeat again because I will configure internal self IP. So I will type internal self IP. Okay, so this is our internal self IP. Okay, so I will use also a /16. Then I'm going to use internal because this is internal. Then allow none. Okay, then finish. Okay, so now I have external self IP 10.10.1.252 and internal self IP 172.16.1.252, and I map them on their VLAN, the one that we created. Okay, so our next step is configure HTTP and HTTPS virtual server, and let's go to and configure full members on this virtual server. So all we have to do is go to the local traffic, virtual server list. Okay, now you need to click create, and I'll put HTTP BS. So this is our virtual server. We can also put maybe the IP address of our virtual server. This is just an optional 10.10.1.101. So in our case, this is our virtual server, or I think maybe if I will copy, or it's just the same, I'll copy. Okay, then I'll put HTTP virtual server. Okay, then I will use a standard, and I'll put destination address. My IP will be this one, 10.10.1.101. Okay, then since this is HTTP, I will put port 80. Okay, then before I will save this one, let's try to go to our Windows 10 machine if I can ping this one before I'll save that one. So let me go to our jump server, our client machine. Okay, ping 10.10.1.100, right? See, it's not pingable, right? So it is currently down. So we'll do a continuous ping and let's see. So we'll go back here, 10.10.101. Oh, 101. So we'll go to, did I put ping 100? 101. Okay, it's not pingable. 101 is also down. So let's go to our BIF. So HTTP BIF. So what else here? So if you're going to configure SSL SSL. We're going to configure only SSL pass-through because we don't have certificate on this device, so we cannot configure SSL bridging and SSL bridging and SSL offloading. So we're just configure SSL pass-through. So let's go to our, then we need to configure our source address translation. We are going to use automap. Automap meaning it will use our self IP for that backend communication between your pool member and your F5. If you can also use SNAT, but we're not going to use SNAT. SNAT, you can configure a pool range of IP address, so you can use that one so that your we will use that one to communicate to your pool member. So in our case, we'll just use automap. Okay, then we'll just use this one as a default. We're not going to configure IRUs for this time. Then if you can see here, default pool member, none. So I'll click, I will add a pool member. Now we are now here, configure HTTP pool member. Okay, so I will click this plus button. Then I'll just put HTTP pool. Okay, description is just an optional. Then I'm going to health monitor, we'll just configure later. So load balancing method, you can use round robin, ratio, or least connection, or this one. So in our best lab, we're just going to use round robin. That is our number 5. Okay, we're going to use round robin, and now we can start adding a new node. Okay, so in our we're going to add those server now. So I'll just put 172 or app 1 HTTP. Okay, so 172.16.20.1. so app 1 HTTP 172. Then I'll put port 80. Okay, then I'll just click add. Now we have app 1. We have now server, so we're going to add another one. I'll put app 2 172.16.20.2 port 80 as well, add. Okay, then we're going to add the third server, 172.16.20.3, add. Okay, so I'm going to click finish now, so we can complete the full member with this node. Okay, finish. So we have now full member for this VIF. So I need to save this one. Before I save, let's check our continuous ping if it's there. So we still not doing the ping, right? So let me do ping. Okay, I will save it now. Finish. Okay, so our virtual server is up now. Let's check our see, now we can ping the virtual server from our Windows machine. See, we can ping now our HTTP from here. So next we're going to configure also our HTTPS virtual server. So same procedure, click create. Okay, then HTTPS BS 10.10.1.102, our IP address. We can put description if you want. For our testing, we can skip that one. Then we're going to use this IP address for our destination, and this time we're going to use 443 because we're using HTTPS for our virtual server. Okay, so we'll use that one as a default because we're not using SSL profile. Then we're going to use a source NAT automap. Then we're going to use also pool member. So we're not using that pool member. We're going to add a new pool member for our HTTPS. So HTTPS pool. Okay. Then we also configure round robin, and now we're going to add our IP our app um, app app one. We can use the same um, server, but let me try if I can rename them. App one is TPS 172.16.20.1 443 app one is TPS. Okay, add. So we're going to add HTTPS same 2 and 3 add. Okay, so we can now finish this one. Full member nodes and existing node. Okay, because there is like a duplicate name, so what I will do, I'll just use I'll delete this one, delete. Okay, I'll click finish. Then I will go to nodes. I'll rename this one if I can rename them. No, I can't. I cannot rename them. So in this case, I can use the same name. Okay, so I'll go to full list. Okay, HTTP pool member. Then I can add them. I can add those one. Node list 443 is just a name, right? Add, repeat. So 443 repeat, then 443 finish. Okay, 443, then okay, so update. I will update this. So okay, so now I have a two full member for HTTP and HTTPS. Okay, so in our virtual server now, virtual server, we did not yet save our virtual server, so let me create again. It's HTTPS BS 10.1102. Okay, then we're going to copy this one and put it on our destination IP address, and we'll use 443. Then we're going to use automap. Then for our pool, we're going to select our HTTP pool, then click finish. Okay, so we should able to ping now our HTTPS 102. Yeah, you can ping it. Okay, so we finished the up to configure round robin. Okay, then we'll verify if round robin is working, because round robin is like if you have a 3 server. Okay, if you have 3 server, first connection it will go to the server 1, second connection it will go to server 2, third connection it will go to server 3, fourth connection it will go to server 1, fifth connection it will go to server 2, 6 connection, it will go to server 3. That is round robin. Okay, so let's verify if that is really working. So we'll go to our jump server, our Windows machine. Let's open our Chrome. We're going to access our HTTP 10.10.1.101. This is our HTTP. Okay, we can access our server. We can see here server 1 172.16.20.1. We're now connected to our server, and our client IP address is 172.16. This is our self IP. Okay, we're using source port 56375, right? And our source is the Windows. Our source is the Windows machine, right? 10.10.1.4. If I will go here, source IP address, your source, okay, your source address 172.16.1.252. This is our self IP. Okay, this is our self IP 172.16.252. okay, so, and we are connected to our virtual server, and it's connected now to our second server. Let's refresh it. It's connected to third server. Refresh. Server 1, server 2, server 3, 1 2 3, 1 2 3. See, our round robin is working properly, right? So let's also refresh here. Server 3, server 1 2 3. Okay, so round robin is working fine. Okay, so what about our HTTPS? 10.10.1.102 HTTPS. This is our HTTPS. So we don't have certificate, so we'll just click proceed. Okay, so our HTTPS also looks fine. Currently we are connected on server 2 on port 443, and we have our self IP that is connected on source 56411. In our, so let me refresh it. Let's check the server 2 if it's changing. Server 1, server 3, 2, 1, 3, 1, 2. See, it's changing. Even here, server is changing. You can see the blue one, 1 2 3, 1 2 3. See, it's changing also. So round robin, it's working. So now let's try to configure health monitor. Let's try to use like ICMP, and maybe we can use also HTTP and HTTPS and ICMP. Let's see if this one will work. Okay, so all you have to do is go to our full name. Okay, let's test first this one. So HTTP, we can use health monitor HTTP. Since our VIP is HTTP, we can use this one. You can also use multiple health monitor. In this case, we're going to use HTTP, then update. Now this one, it will turn to green, right? See, now it's showing green because we can health monitor is port 80 is working, right? So same in our, let's go to our, see, this one is blue because we don't have a health monitor. Let's go to our HTTP and monitor. We can configure this one. We can since this one is HTTPS, we can use HTTPS, right? Then update. This one will turn to green now. See, it's green now, right? We can let's try to remove it. Update. See, it went to blue. So let's try to use ICMP. Let's try gateway ICMP and see. Update. See, so health monitor is working fine. On our HTTPS we're using ICMP, and in our HTTP we're using HTTP health monitor. So we finished number 6, so now we are in number 7. Let's try to configure priority group and verify. So in our scenario here, for example, if I will go to our HTTPS profile, right, member. So right now priority group is 0, everyone is 0. What we're going to do, we're going to configure priority group for server 1 and server 2, and server 3 is just a backup. So I will click this server, okay, then I will configure priority group. Maybe I'll put 10, okay, then update. Then priority group member, no, it's HTTPS members. We have now priority group 10 here. Let's put also this one as a priority group 10. Priority group 10. So now our member, we have 2 priority group. Now we can use this option now, priority group activation less than, I'll put less than 2, less than 2, update. Let's see what will happen. Okay, so if we're going to our server now on our HTTPS, let's try to refresh this one. Server 1, server 1, server 1, server 1, server 2. See, server 1, it's not going to our server 3 anymore, because our configuration is we have a priority group, right? Server 1, server 2. See, even if I will go here, look at this blue, okay? Server 2, server 1, server 2, server 1. See, that means our priority group is working. So what will happen if I will force offline this one? Because our condition less than 2, right, for available members. Force offline, then I will update it. Okay, so let's try to check it again. So HTTPS server 1, server 1 and server 3. It's server 3 now is taking the load, because our condition is less than 2, since only 1 is up on our priority. That's why it's taking the load from the up 3 server, right? So what if I will change priority group into 1? So what will happen? So I'm expecting all the traffic only will go to server 1, because the condition is true here. So let's go there. Server 1, see, only server 1, it's not going anywhere, only server 1. So our priority group is working, right? So let me put this one into 2. So let's see. Then I will enable this one, so it will take the load again. Okay, so if I will go to our or our Windows machine, server 1, server 2, server 1, server 2. See, our application is working using round robin and priority group. So we tested the priority group, we tested also for softline on other full member. So our last topic will going to configure enable packet capture in LTM and read and analyze packet capture. So in this case, we're going to use our Windows machine. Okay, so let's try to capture this HTTP because so we can see the plain text, right? So in our case, let's try to access the server using telnet I mean PATI 192.168.2.203. okay, then let's put our username and the password. Okay, so let me make it big a little so that you can read properly. Okay, so okay, let me align it. Okay, so in our task here, we're going to run a packet capture. So what I did, I already created the text. We'll just copy and paste it. I can share this to you so you can use it. So in our case, in our desktop, I have a notes here. Okay, so we're going to copy this one. So in this case, we're going to run TCP dumps for our in our F5 LTM, then run this command. These are the commands that you need. Minus S0, then space, minus NNI 0 dot 0 colon NNMP host 10.10.1.101, and you can also put port here if you want port, but in this case we're going to capture everything, and we're going to save in our bar temp capture pickup. Okay, this is our file. So we're going to capture HTTP capture. This is our capture name. We'll just copy this one and paste it here. Okay, so right now our capture is running. Okay, so we're going to refresh this page because we're doing packet capture on this one. So 10.10.1.101. See, we have traffic. Let's take a note of this capture. Source port 56917. Okay, source port. Oops. Let me save 56917. Okay, then we're going to stop the capture. See, we have 419 capture. Now we need WinSCP so we can download the capture. So WinSCP, let's download the capture and let's analyze the capture. So SCP 192.168.2.203. Our IP address, username and password. Okay, so we're going to bar TM temp and HTTP. Where's our capture? HTTP capture here. Let's go into save. Let's save it in the. Let's save it here in the drive. Drive E. Okay. So let's try to open it from there. So let's try to open it. Let's go to our. Where's our jump server? Windows 10. We're going to drive D and HTTP, this one. Okay, so we're going to check our capture. Let's check our source. This is the source port of our backend server, right? Let's try to find this one. TCP port equals okay, see, this is our backend communication from our self IP towards the server. There is a sync ACK, then the application, HTTP 1.1, then we saw ACK here from the server, then we get a reply to 100 OK, then fin ACK, fin ACK, right? So if we're going to follow this stream, okay, see, this is the one that we are seeing. If you're going to curl it, you will see the same like this. Then, so this is stream 33, so I'm expecting stream 32 will be our front-end connection. So our front-end connection is this one. So it will see from our Windows machine to our virtual IP server. We have also seen ACK, HTTP application, 200 OK, fin ACK, fin. See, so if you're using maybe because I'm using virtual machine, usually you have a F5 frame here, so you can see the front end and back end using that deep information. But unfortunately here, the workaround, I'll just go to TCP stream equal 32 on 33. That is the front end, and this is the back end communication based on our based on this capture, right? So so where's our checklist? Okay, so we completed our lab. We configured the VLAN. We configured the external and interface VLAN. We configured the interface self IP for external and internal. We configured the virtual BIF HTTPS virtual server. Then we configured their full members. We configure also round robin and verify if it's working. We configure health monitor, and we configure priority group, and we try to do ports offline. We enabled packet capture and we analyzed the packet capture. So we completed our lab. I hope you enjoyed this video. Thank you for watching. Please support my channel. Click like and subscribe.